as I said in the last video, the myocardium, all this pink stuff here, the middle layer of the heart, middle layer of the heart wall, is made primarily of of contractile muscle fibers, or the muscle cells of the heart, basically. 1% of the cells that we're looking at here are called autorhythmic cells, or cardiac pacemaker cells. And the 1%, just so you have a visual on this, they're buried inside of the myocardium, but they're represented by all of these gold structures here. So we're going to talk about all of these different structures we're looking at here. But just so you know, all of these golden little threads here and the little beans are made entirely of autorhythmic cells. So that's the 1%. What these guys do is they depolarize spontaneously. They pace the heart internally, which is very special. They allow for us to not require the central nervous system to be having an input in order to allow for the heart to beat. Everything is internal or endogenous to the heart. And the way that it works is what we call a pacemaker potential. So this is what we call an unstable resting potential. I want you to copy this into your notebook right away. There's a lot of little details in there here, and when you force yourself to draw them by hand, you will pick up on some details that you might not get just by staring at the thing. So give it your best shot. Try to draw it in there, and then we are going to be covering these together in class as well. I will be redrawing it for you, but I want you to give it a try to draw it now. I think it's a good way to learn it. And then you might not have to redraw it when we're in class. We can just talk about it. So this is called a pacemaker potential. The idea behind a pacemaker potential is that it continuously depolarizes because of the presence of a slow sodium inward leak. So it's constantly drifting toward the dotted line right there, threshold. It's constantly drifting toward threshold, and once it reaches threshold, very similar to an action potential, it allows for the fast influx of sodium as a depolarization. It also has calcium influxing, and then it has potassium effluxing during the repolarizing stage. So you see some similarities here with the neurons and with the action potentials. But the main difference, I think, is that constant drift upward, which neurons, action potentials, do not exhibit.